In exercise 3.5.1, we have to go back to exercise 3.2.4. And as you can see in exercise 3.2.4, we have a random variable s, which has a compound Poisson distribution with intensity parameter lambda equal to 2 and with a probability function px, which is given by x over 10. And the question is the same as in exercise 3.2.4. We have to determine the probability function of the random variable s. And what we will do is the following. We will start with theorem 3.5.1, where you can find Panjer's recursion. And then in the book, in exercise or in example 3.5.2, we applied Panjer's recursion for a compound Poisson distribution. In this exercise 3.5.1, we can be a bit more concrete even than in example 3.5.2, because now we know that lambda is equal to 2 and we have the function px. So let's see how we can solve this exercise. We have that the probability function of the random variable s is denoted by the function f. And using the results of example 3.5.2, we have that f in 0, so the probability that your total claim amount s is equal to 0, this is equal to e to the power lambda p0 minus 1. In our situation, lambda is equal to 2 and p0 is equal to 0, so you find here e to the power minus 2. For s equal to 1, 2, 3 and so on, we have that fs, the probability that your total claim amount s is equal to small s. This probability is given by lambda divided by s. And then I have a sum where h runs from 1 all the way to s, h, p, h, and then the probability function of s evaluated in s minus h. And then you see it's a recursion, meaning that once I have the function f for values below s, so s minus 1, s minus 2, all the way to 0, I can calculate the next value f in s. For example, if I need to calculate f1, so I already have f0 here. So from f0 I can jump to f1, because f1 is equal to lambda divided by s, and s is now equal to 1. My summation, if s is equal to 1, is just one term, so I have h equal to 1, p in 1 times the function f in s and h are both equal to 1, so here I have f0, and I already calculated this f0 in the previous step. If I fill in that p1 is equal to 1 over 10 and f0 is equal to e to the power minus 2, you find here 1 over 5 e to the power minus 2. Let's now calculate f2. f2 means that s is equal to 2, so this s is equal to 2, so now I have two terms in my summation. Lambda is still equal to 2, divided by s, which is also equal to 2. My two terms are, first, I put h equal to 1, so I have 1, p 1, f, s minus h is now 1. Plus then h equal to 2 is 2 times p 2, f applied in s minus h, which is now f0. We know that p1 is equal to 1 over 10, p2 is equal to 2 over 10, f0 was calculated in this step, and f1 is calculated in the previous step. So using the results of the previous and the first step, you can know all the numerical values. If you put it all together, you get 21 divided by 50 e to the power minus 2. Same holds for f3. Now we have lambda equal to 2, s equal to 3. h equal to 1 gives you p1, f2. Plus h equal to 2 gives you 2, p2, f1. And h equal to 3 gives you 3, p3, f0. Again, the f0 was calculated in step 1. The f1 was calculated in this step. And from the previous step, we also have f2. That comes from the previous step. You can then plug in all the values to get 511 divided by 750 e to the power minus 2. If you continue like this, you find that f4 now has 4 terms. We need f0, f1, f2 and f3. If you put all together, you get this outcome for f4. And that solves your exercise.